Okay. Very good morning to everybody. Today I'll be talking about neural attention rating regression with review level explanation, or short form NARE. Okay, so let's get into it. We have 4 things today: motivations for this paper, the methodology, experiments, and the results. So let's talk about 2 motivations. So the motivation is that past papers do not consider the contribution of each review in modeling the recommendation. Or the explanation are simple extraction of words or phrases which twist the meanings of original sentences. So yes. So we have the methodology. So the thing is, for both item and user side, it's a reflection. So we just look at one side and can understand the whole model. So let's start with CNN text processing. So this is a contribution of DeepCon. It's another recommendation model, and it uses CNN as a text processor. So what you do is there's a function to convert or to map every word into a certain vector. So this vector is any vector that is trained by any of the word embedding. So can be word to vec, glove, or whatever. Static vec also can. Yeah. So so then it's put through m number of filters with size k and a certain sliding window, and it follows is followed by max pooling and then a fully connected layer. I think basics of CNN. So I shall not go into that in detail. So let's go into NARE. So NARE has this additional thing called the attention-based review pooling. This is okay. So it's here. So this helps to select the best reviews for the recommendation from the user and from the item. So now we want the output of all the reviews, OIL, for each item and each review. OIL for each item and review. So then we can do an aggregation of these reviews. But not all reviews are as good, as useful, and as representative of the item or the user. So we try to use attention to pick the best review for them. So let's look at how it's done. So the attention network takes a review and a user ID, and it gives an attention score. This is done by a 2-layer neural network, and the final weights are obtained by a softmax layer. So then the attention score is AIL, given by softmax. So as simple as that. So a CNN in the review plus the ID of the review, and we get a score of the attention. Then once we have the score of the attention, now we can get an attention weighted average instead of simple average. So then this helps us to select the best reviews for the recommendation. And finally, this concatenated output of the review goes into a neural network, give the final representation for the item or the user, depending on which side of the network is in. So now let's talk about prediction. So in prediction, it's pretty simple. There's only 2 things. So they use latent matrix factorization, and there is the user embedding, which is the one we have using explicit reviews, and the one that we generated, which is X. So then we have LFM using this, and then we can do a prediction using a neural network as well, a fully connected layer. So this is basic using LFM. So nothing much difference, except the introduction of the additional features. So the training is done on squared loss, and is done end-to-end. There's dropout in a few layers: the attention layer, the FCN after obtaining the overall review, and the final prediction layer. This is to prevent overfitting. And the contributions in this paper there are 3. So you can see here, NARE gives ratings, users ratings, textual reviews, deep learning, and the review usefulness, depending on the attention of the review. So then there's 3 contributions. They have the novel idea of different reviews having different usefulness to different users, and they use neural attention in building recommendation modeling, and finally they achieve state-of-the-art result at that time. So we can see that the results are accurate and explainable. So the results are accurate. So you can see that Nari performed better than the rest of the models then, and you can see that it selects good reviews to help in the recommendation. So you can see here that this review has a weight of has an attention weight of 0.19. These brushes are great quality for art, structural artwork. They seem to last well and blah blah blah. So this is a good review. Whereas I bought it for a gift for my daughter as a gift. It's not very good for helping in recommendation. So the attention system does well in this case, and also it allows you to give this review to the user to understand why this item is recommended for you. Yeah. So same thing for the other item. Again, Nari fares better than using latest, random, or longest review for prediction. So instead of using Nari, the attention score, we use the latest, random, or longest, and Nari gives better results at both prediction at 1 and required 1, and prediction at 10 and required precision at 10 and required 10. So yeah, and finally, using crowdsourcing, they ask them to label is the review good for you? Is the review good? So there's a 1 to 4, and the ones selected by Nari is highly rated to be good. So it's better than those that are top rated in the dataset. So the dataset has a label called top reviews, and they have a certain number of helpfulness score. Yeah. So Nari achieves a better result than the one in the dataset. So this is Nari, and I have some questions for the presenter.
A question for you first?
Yeah, go ahead.
If you go back to the review selection.
Reviews?
Yeah.
This one?
No. The result.
This one?
Yes.
Okay.
It seems that in the longest reviews is select rather than the shorter review. And the shorter reviews got the lower score.
Yes and no. We tested it next on the longest review, and if you select all the longest reviews, it not necessarily give you the better score. So meaning that Nari has additional stuff that looking just at the longest review itself. That's why there is let's say if you look by length, it's not scored as well as the one given by Nari. Because Nari doesn't look only at length. It looks at probably the usefulness as well as
it will be different in the criteria. Let's say you length, just based on the length. But if you have too long review, maybe not good. But let's say the medium length reviews may be better.
Yeah, maybe that's why Nari can take account of this kind of things. Yeah.
But this one is whether they just based on the length. I mean the total length, or just on some using some threshold. Okay, that's how many sentences in the review is good, something like that. So maybe you can.
I think it's possible. Yeah, if you want to really test it out, you can use certain different lengths to see the precision and the recall. And I'm not sure whether you'll beat Nari, but I mean, they could try it. You could try it as well.
Okay, so but is there any other qualitative example that they show that okay the reviews are relevant, very strongly relevant to the items, and is support very good?
So this one is difficult because we need to use some qualitative analysis, which they have done using crowdsourcing. So that what they have done is they show certain reviews so like they have 100 users, and they show different reviews and ask them to rate 1 to 4 whether the review is useful with this. And certain the phrase that they give them is this. So let me read it out to you. Your task is so you're going to buy an item, so you want to refer to the written review by previous consumer to know more about the item. So you need to browse each of the review below and then determine whether it's useful per your position, and then you can rate them 1 to 4. So this is what they have done, and it comes up that Nari actually gives good reviews to the user. To the users, because more of the people reading the reviews rate them higher. Yeah.
So it's a ranking or what?
It's not ranking. This is basically people who rate them 1, okay. 2, 3, and 4.
They're only presented with 2, either Nari or the top rated.
They are given no. All they are probably given the same set of reviews, a list of them and ask them to rate all 1 to 4, 1 to 4, 1 to 4, 1 to 4.
So what are the candidates?
The candidates are randomly selected. Let's find it. Okay, so the reviews are randomly selected from the list. Yeah, and there are 1,264 reviews in 100 items.
Okay.
So about.
Okay, and so this figure is what? This correlation, is it?
No, this figure shows that so within that amount of reviews shown to the users,
Right.
so based on the top rated ones, the number of people who give 4 to the top rated reviews is only 49% or something around
So
there.
it looks the same to me.
This one has 50 plus.
Yeah, but the rating 3, that one is a bit lower, right?
Yes.
So if you average out the average rating, probably will be similar.
But it's better because they give 4 to the ones given by Nari instead of the 3.
4. They also give 1 and 2 to the ones by Nari.
Yeah, but lesser.
We
So
have 1 and 2 lesser. Right?
yeah, 1 and 2 is lesser.
1 and 2
Lesser.
is lesser.
Given the one
yes.
given to Nari reviews.
Uh-huh.
And although 3 is lesser, but 4 is higher. So
How do we know the difference is significant?
this is a good question because they didn't do a significance test for this one. Yeah.
No, they have, right? Smaller than 0.01. One
Perform.
No, that's a different.
That's for the
That's a accuracy
yeah,
thing. Right?
precision and
accuracy.
yeah.
This one we compare with the usefulness review based on the ground truth review on the data set. Top rate.
Yeah, but yeah, and they use 3 different person for the same review at least. Yeah. So then there is agreement started.
Author number 1, author number 2, author number 3.
Yeah. No. So they have 100 users, 100 participants in this test, and
So
then
this is crowdsourced. So
yeah,
they do
crowdsourced.
mechanical.
Something like that. Yeah. Yeah, but there's no test on it.
Okay. But is the assumption that making it more accurate and making it better explanation?
Right.
Okay.
Okay. So why is the review that makes the model more accurate also a good explanation?
Okay, can you repeat?
That means why is the same review? I mean, the assumption here is that the same review that makes the model more accurate is also
Better for explanation.
a better explanation.
So the form of explanation here they use the most helpful review to represent to the user. So
The most
basic-
helpful towards recommendation,
Yeah.
towards
Understand.
accuracy, right?
Yeah, correct.
toward the accuracy.
Maybe the features in the review that contributes towards recommendation and contributes to user explanation is about the same because they are in form of some words that are in there.
Instead of just some phrase or something like that, they just represent the whole review.
They don't say that the best explain the review. They just
No, but that's
write based on the
but that's the assumption, right? It means the higher the attention weight, then the better
better the
explanation should be.
Yeah.
Yes.
Yeah. So
That's-
what the accuracy?
Yeah.
And the weight is trained based on the rating.
Yes, correct.
Accuracy.
Yeah.
Maybe they believe the model looks at the review the same way as a human does. Yeah. Like what they look out for in the review.
Because in some sense, if you change the collection of reviews, you may still get a similar accuracy, but you get a different explanation now, right?
Yes.
That's true.
So then what does that mean? Yeah.
simply
score to the user.
how appropriate the review toward the certain rating. That's it.
But the review comes from other users, right?
Yes,
Yep.
correct.
Yeah, the user comes from other users.
From other users.
Yeah, must be.
Okay, so there's two different sites.
Yeah.
Depends on which site it is. One comes from other user and one comes. So the item one comes from other users,
Yeah.
whereas the user one comes from yourself.
That it should
Yeah.
be from other user.
Okay.
Yeah.
It's by an item.
Then finally, you can give the best one for that user.
Well, I think it's okay because all those reviews talking about the same item.
So I'm not sure, yeah, because so by right they should be testing it with multiple reviews, right? Because I cannot be sure. I might just be lucky that the best review, the one best review, happens to be good. But this is dependent on the sample that I have. Because every time you change the collection of reviews, I get a different explanation.
Yes, understand.
So then we should do this multiple times with different subsets of the reviews to see whether or not every time I pick the best explanation is still repeatable.
I get what you mean. But if you cut down the data set size, then you'll probably affect the performance as well, right? Then, yeah.
But I'm just guessing. The performance will be similar. If you just remove things, but the explanation may be different. So this counts because the explanation is selected, right? Means they don't
Yes.
actually have a model for the explanation.
No, it's selected through the score, through the attention score. So, would you like your questions now?
Yeah.
Okay. So, the questions for the presenter. So, let's start. Okay, let's look at the attentive multi-view. So, in this, what if the length of different path is vastly different? Does it still make sense? Let's say food is here, drinks is here, maybe wheat and wine is here, then the last layer is something like that. But maybe there could be some other stuff below. Yeah. That still makes sense because what they show here is that, oh, maybe meat, drink, and fruit are on the same layer, which makes a certain category, or certain size. Yeah. So that still makes sense. Could the improvement of the model, so number 2, be due to the introduction of external data, which is the Microsoft the graph, and also the hierarchical propagation, and not the multi-view itself? So what if we just put EFM here with your hierarchical axis, but using one EFM to predict the rating? Will we still have the same results? Maybe this hierarchical thing doesn't even work at all because they didn't test it.
You mean that every works?
We still have the hierarchy here. We get access.
We use EFM only, right?
Sorry? Yeah, we
When
use
we-
EFM only.
And we use EFM only, so we don't have the hierarchical.
You can have the hierarchy.
Well,
You can have the
just
axis.
A set of works, right?
No, but you propagate the axis.
What do you mean by propagate the
So,
X?
okay, in EFM itself, you have x, right?
Yep.
X1, X2, X3, right?
Yep.
But now it's x tilde 1, x tilde 2, x tilde 3 because they propagate.
Yep.
Yeah, so they still use the attention and the x tilde.
Yeah.
So instead of using multi-view EFM, you just have one EFM with x tilde as your input.
Oh, okay.
Yeah.
I see.
So maybe this one doesn't really help. They didn't test it, so yeah.
Yeah.
So then lastly, the authors didn't say whether it's significant, and the results are less than 1%. So it's
Yeah.
yeah. So this is quite important. And what happens if there are one-to-many relationships? Yeah, I think.
What do you mean by one-to-many?
So in the Microsoft graph, there could be, like, let's say, maybe seafood and some things is also meat. Well, this one was also seafood, so it can be both.
So it's a deck.
Yeah, it's a deck instead of a tree. Yeah. So then what do we do? So I think that's all the 4 questions. Yeah.
That's true. I think they mentioned in the paper.
Answer one.
Okay. Okay, inside the paper they mentioned about they fix the height of the different layer. They try different view to investigate which one is the best setting or something like that. I guess for the problem of different height of the back, right? I think there's no problem because the formula it's just accumulate it's just add on the children node to the parent, right? So we if we don't have the children here, for example here we don't have children, right? But we just add one children to its parent node, so it's still have
But the multi-view EFM takes the whole layer. And counts out
yeah.
the
It's
attention from-
will based on the root, right? So what I know what you mean is that the meat and the drink and the fruit here they are in a different level, but they also have personalized explanation generation, right? They will capture each term in each track from the root to the lip. So maybe if this layer have the highest score, they will suggest drinks instead of wine, right? If wine have a higher attention score, they will suggest wine instead of drink. So this two cannot be cannot come together in the explanation.
Yeah, but meat will affect the wine now.
Why?
Because they are in the same view.
They're in the same view. But I'm not sure we can test that, right? I'm not sure how it's affect. Maybe a different way have different result. But the idea is that when we have the construct this one, we can push to the model. The model have the architecture flexible, so we can. So for the second question, what if we change this one with if m, right? We can try.
Not EFM, but EFM plus maybe, but without the multi.
Okay. I see what you mean. So I think that's a good point. The author may test with the event plus to see whether it's come from the multi-view contribution or the event itself. So but I'm not sure how about the attention layer here. And for the prediction, maybe they use if they just use the simple bias term, right, to have the predictions. But I think that's a good point to compare, right? Yeah, we will know exactly which part will contribute to the model. This part or the model itself, the architecture itself. So for this one, to be sure, it's not significant.
Oh, okay.
Yeah. So if it's significant, they will mention in the paper. Yeah. In the paper, they just mention for with the EFM. Maybe this one they use EFM with different term, but I'm not sure that they use X style with the attention layer. Maybe they just use the EFM in the traditional way instead. They just use different work term as the feature to compare. So it's unfair advantage, right? I see the good point. Okay. The last one. What happens if there are one many relationship? I'm sure that for the in my slide. Okay. Okay. What the author mentioned is that if concept is a relationship, they will construct a parent to the children. So if they have the multiple relationship like different work term, they may consider that are two different work. I see. Yeah. So have a okay. Are you satisfied with the?
I have one more question. After Ween present about the narrate,
Yeah, narrate.
So in narrate they also select some reviews as some part of the recommendation.
Correct.
Why in the qualitative result it show the explanation for recommendation? Why this paper not compared to narrate?
Narrate, different form, right? We have the full review. With this one is just a template, right?
But it compares to the PAV, right?
Yeah, it gives
Yeah.
keywords.
But they still compare to the PAV.
Yeah, just have a what I think what the point is that they try to compare with the FM only, but to signify the explanation is make more sense than the very simple explanations like people so view on the item also bought with this item or something like that. So it make more sense for guide the user to rate them higher score for the user study.
But in terms of explanation, I think it still can somehow compare to the narrate.
Yeah, you're correct. In my recent work, I compare all of them. So the result is that the review is better than this one because this one is just redundant. They duplicate, right? When we have something like another feature, they just come something like that. Focus on these different sentence have the same. So this is just a generic explanation. It's cannot applicable. It's not applicable for all the cases.